Good morning. Today's topic is piezo-resistive transducer gauge factor and introduction to photodiode. Okay, so these two topics are very important concepts. Okay, so here now we are moving on to piezo-resistive transducer means strain gauge factor. Okay, strain gauge factor. So here, if you see, strain gauge is a resistive transducer. It is a resistive transducer. Okay, it is a resistive transducer. So the resistance of strain gauge varies with applied stress. Okay. So let us suppose this is a strain gauge material having cross sectional area A, having cross sectional area A. This is cross sectional area A, I call it. So D is the diameter of the strain gauge wire and L is the length of strain gauge wire. L is the length of strain gauge wire. So let us suppose this strain gauge material is subjected to stress by applying force. By applying force. Okay. So now the force is applied like this. Means I am stretching this material, strain gauge material. If I stretch this strain gauge material, what will happen? See here, the length of material will increase and diameter of wire will decrease. Length of wire will increase and diameter of wire will decrease. So let delta L be the change in length. Actually, L is the length of this strain gauge material. A is the cross-sectional area of strain gauge material. D is the diameter of this strain gauge material. Okay. So R equal to rho L by A is the resistance of strain gauge wire. Now, this strain gauge material is subjected to stress by applying some force like this. Let us take a rubber band. The rubber band length is L and the diameter of rubber band, let us take it is as D. D is the diameter of rubber band. If you stretch the rubber band, then what will happen? Length will increase. Length will increase and the diameter tends to decrease. Diameter tends to decrease. Okay. That's it I am telling here. So change in length is delta L. Change in diameter is delta D. Change in diameter is delta D. Since length is increasing, let us suppose delta L is the length here, which is increment to its original value. So length is increasing now. So total length will become L plus delta L. L plus delta L will be the length, total length of a strain gauge material. And diameter is decreasing here. So D is the actual diameter and there is a change of delta D. Let us suppose delta D is the change in diameter. So diameter is decreasing. So D minus delta D is the actual diameter now after applying force. After applying force. Okay. So here this diameter is varying. This diameter is varying due to applied stress. Okay, applied stress. So this diameter is varying due to applied stress. So R equal to rho L by A kada. R equal to rho L by A. Okay, this is resistance. Okay, R equal to rho L by A. So differentiate this equation with respect to stress. So what will become, see here, I can write this equation as R equal to rho, R equal to rho L into 1 by A. I can write like this. Is it right or wrong? Rho L by A, rho into L into 1 by A. So differentiate this R with respect to stress, because I'm applying stress now. So due to stress, there is a change in resistance. That's why. So what I want to find now is, see here, the resistance is changing if rho varies or L varies or 1 by A varies, area varies. Area marina R marutundi, resistance marutundi. Length marina resistance marutundi. Rho marina resistance marutundi. Now what is here happening? Due to applied force, length is increasing and diameter is decreasing. Since diameter is decreasing, cross-section area is also decreasing. This is cross-section area, this is decreasing. So resistance is varying due to combined effect of length, area and resistivity rho. So here, due to the combined effect here, R is varying due to combined effect of rho, L and area. Okay, rho, L and area. It is due to all this. It is a combined effect. Right? So what I want to do is, I want to measure what percentage of change in length, results in change in resistance. What amount of change in area results in change in resistance. What amount of change in resistivity results in change in resistance. I want this. అంటే ఈ రో ఎల్ ఏరియా మారటం వలన రెసిస్టెన్స్ మారుతుంది. అయితే ఇప్పుడు నాకు ఇదంతా కంబైన్డ్ ఎఫెక్ట్ అన్నమాట. రో ఎందుకంటే ఫోర్స్ పెంచుతుంటే లెంత్ పెరిగిపోతుంది, డయామీటర్ తగ్గిపోతుంది, అంటే ఏరియా తగ్గిపోతుంది, క్రాస్ ఏరియా తగ్గిపోతుంది, లెంత్ మారిపోతుంది, క్రాస్ ఏరియా మారిపోతుంది. అంటే ఇట్స్ కంబైన్డ్ ఎఫెక్ట్ అన్నమాట. ఇది రెసిస్టెన్స్ మారడం అనేది కంబైన్డ్ ఎఫెక్ట్. ఇప్పుడు ఈ రెసిస్టెన్స్ మారడం అనేది కంబైన్డ్ ఎఫెక్ట్. ఇప్పుడు నాకేం కావాలి అంటే, లెంత్ లో మార్పుల వలన రెసిస్టెన్స్ ఎంత మారుతుంది, ఏరియాలో మార్పుల వలన రెసిస్టెన్స్ ఎంత మారుతుంది, అది కావాలి. అయితే అలాగే రో మారటం వల్ల రెసిస్టెన్స్ ఎంత మారుతుంది, ఇది నాకు కావాలి. ఓకే, సో ఐ నీడ్ not combined effect, I need individual effect which changes in resistance. ఇది నాకు కావాలి. సో అసలు ఎందుకు మారుతుంది ఇది? స్ట్రెస్ అప్లై చేశాను, ఫోర్స్ అప్లై చేయడం వల్ల స్ట్రెస్ అయింది వైర్, అందుకు మారింది. సో డ్యూ టు అప్లైడ్ స్ట్రెస్ ఇది మారుతుంది అనమాట. కాబట్టి దీన్ని dr బై ds చేయండి. I'm taking partial differentiation here. Why? Because there are individual changes here. So dou of rho L by A by dou S. ఇది నాకు కావాలన్నమాట. ఇప్పుడు మన ఫార్ములా ఏంటి? డో ఇప్పుడు నా ఫార్ములా ఏంటి? డో బై డో ఎక్స్ ఆఫ్ యు వి డబ్ల్యూ అని ఉంటే కనుక నాకు ఫార్ములా ఏంటండి దీనికి? యు డాష్ ఇంటూ వి ఇంటూ డబ్ల్యూ ప్లస్ యు ఇంటూ వి డాష్ ఇంటూ డబ్ల్యూ ప్లస్ యు వి డబ్ల్యూ డాష్. ఇది నాకు పార్షియల్ డిఫరెన్షియేషన్ అన్నమాట ఫార్ములా. సో ఇది యు అనుకోండి, ఇది వి అనుకోండి, ఇది డబ్ల్యూ అనుకోండి. సో అప్పుడు నాకేమొస్తుందండి? కొంచెం ఈక్వేషన్ మర్చిపోండి. దిస్ ఇస్ డైరెక్ట్ స్టెప్. దిస్ ఇస్ ఏ డైరెక్ట్ స్టెప్ హియర్. ఓకే, సో ఇది సాల్వ్ చేస్తే ఇలాగే వస్తుంది, రైట్? సో నౌ డో బై డో ఎస్ ఆఫ్ అంటే dr by ds equal to dr by ds equal to u dash vw. u dash అంటే u అంటే డో, కాబట్టి డో రో బై డో ఎస్, డో రో బై డో ఎస్ ఇంటూ ఎల్ ఇంటూ 1/a ఇంటూ ఎల్ ఇంటూ 1/a అంటే ఎల్ బై అని రాసుకోవచ్చు కదా, ఎల్ బై ఏ. ఓకే, ప్లస్ ఇప్పుడు ఇప్పుడు యు రాసుకోవాలి అంటే రో వి డాష్ అంటే ఎల్ డాష్. ఎల్ డాష్ మీన్స్ డో ఎల్ చేంజ్ ఇన్ లెంత్ బై అప్లైడ్ స్ట్రెస్ ప్లస్ యువి సారీ u v dash into w ఉంది ఇక్కడ. w అంటే ఏంటి ఇక్కడ? 1/a. సో I can write it here like rho by a. Okay, plus uv. u means rho, v means l into w dash అంటే డో ఇంటూ డో ఆఫ్ 1/a by డో ఎస్. ఓకే, you have to define this. So d by dx of 1/x minus 1/x square formula. So into the differentiation అండి 1/a differentiation. Okay, d by dx of 1/x minus 1/x square. So minus 1/a square into మళ్ళీ I have to differentiate a here. So dou a by dou s. Dou a by dou s. Okay, so this I have written here. See, dr by ds equal to dou rho by dou s, dou rho by dou s into l by a. Here it is. I will mark this with another color. First of all, I will erase unwanted matter. Okay, this I am writing here. Let's see here, dou rho by dou s into L by A. Where it is? Here it is. Okay, rho by A into dou L by dou s. Where it is? Here it is. plus into minus, minus rho L by A square into dou A by dou S, minus rho L by A square dou A by dou S. This I have here now. What is this? dr by ds means delta R it is. This is delta R. Okay, delta R. Dou R by dou S means change in resistance. With respect to stress, it means change in resistance means delta R. Okay, I am clearing this now. See now. Now see here. So how I am writing this equation in other form. Dou R by dou S means delta R. Delta R, I can write like this also. Delta R equal to rho by A, rho by A, 1 second. Rho by A. Dou L by dou S means change in length by applied stress. That I call it delta L. Change in length plus minus rho L by A square. Dou A by dou S means change in area. I call it delta A plus L by A, L by A. Dou rho by dou S means change in resistivity, delta rho, delta rho. So delta R equal to rho by A into delta L minus rho L by A square into delta A plus L by A into delta rho. Right? What I want now, change in resistance to original resistance. Okay, change in resistance to original resistance. This is the change in resistance, delta R by delta S. This is the change in resistance. This is original resistance. This is original resistance. So I need change in resistance means delta R, change in resistance delta R by original resistance R, delta R by R. So this is delta R, isn't it? Change in resistance by original with respect to stress. This is delta R. This is R. So let us put this equation 2. This is equation 1. So 2 by 1. Delta R by R means this is delta R. This is R. Delta R by R means 2 by 1. Okay. So divide equation 2 with equation 1. Divide equation 2 with equation 1. This is equation 1. Okay. So I will take red color because it is visible clearly. So delta R by delta S by R, I am writing directly. Okay. Here divided by R means rho L by A. Rho L by A. Again here by rho L by A. Again divide here rho L by A. So A gets cancelled, rho gets cancelled. Here rho L gets cancelled, A and square becomes cancelled here. L cancel, A cancel. So let us suppose this. Delta R by delta S means delta R. Sorry, dou R by dou S means delta R. So delta R by, this is original R. R equal to, here I am with L. Here I am with dou L by dou S. So I can write dou L by dou S means delta L. Delta L by, here there is L here. Delta L by L minus, all it cancel here. Here I am with A. This is dou A by dou S means delta A. Delta A by A, I am with here. Okay. And here I am with plus dou rho by dou S means delta rho. Here A and L gets cancelled. A, L gets cancelled. There is rho here. So delta rho by rho. So dr by ds is equal to delta L by L minus delta A by A plus delta rho by rho. This is the equation now. Okay. Keep in mind this thing. And here you are taking it as D, not A, not area. You are taking a diameter here. So diameter, now you want to change diameter into area. You have to change diameter into area. So I am taking this now. Area equal to pi by 4 d square. This is the formula. Okay, this is the formula. Pi by 4 into d square. So differentiate this area. You will get pi 2d by 4. You will get here. So pi d by 2 you are getting here. So dou A equal to pi d by 2 into dou d. D dou A by A. Dou A means this one. Okay, this thing. Dou A means this one. Dou A by actual area equal to pi d by 2 into dou d by d. So pi d by 2 into dou d by d means pi d square by 4. So 2 dou d by d I am getting here. 2 dou d by d. Okay. This I am getting here. Since diameter is decreasing, I have to put here negative. Okay. So I will clear this so that you will be able to see this clearly. See here, dr or delta r, both the same, by r equal to dl by l, dou rho or d rho by rho. Okay, this is dou A here. Is A here. Sorry, I am erasing this also. Dou A by A. Dou A by A means 2d to dou d by d. So minus it is here 2 dou d by d. Now I am changing area into diameter now, like this, from this equation. Okay. Now what is happening? See here. Change the total equation with dou L by L. Divide the total equation by delta L by L. Okay. So if you divide total equation by delta L by L, then delta R by dou L by L, dou or d or delta is an obtained equal to dou rho by dou L by L. It is cancelled here. Why? Because it is delta L by L. It's cancelled now. So 2 dou d by delta L by L. What is delta L by L? See here, Poisson's ratio is given as lateral strain by longitudinal strain. Poisson's equation is given as lateral strain by longitudinal strain. So what do you mean by lateral strain? What do you mean by a lateral strain? Change in diameter, change in dimension laterally means diameter wise. So dou d by d. Okay, dou d by d I have to write. Dou d means change diameter by original diameter is the lateral strain by longitudinal strain means lengthwise changes anamata. So dou L by L. See, length is increasing, that's why it is positive. Diameter is decreasing, that's why it's negative. So this equation came like this. Minus dou d by d by dou L by L is called Poisson's ratio. Okay. This is called gauge factor. Changing the distance by changing the distance to original distance by changing length by original length. It's called gauge factor equal to. See here, I'm taking one here. Okay. So minus 2 into dou d by d by dou L by L means, see here, minus dou d by d by dou L by L means what? Poisson's ratio V. So minus this thing. My 2 here, 2 is there here. Minus dou d by dou L by L means Poisson's ratio V. Plus this term is here. Delta rho by delta L by L. Okay. Now 1 plus 2V plus delta rho by delta L by L. This is the main formula. Okay. Since resistivity of material doesn't change, actually. So dou rho becomes 0. 0 by rho becomes 0. 0 by something becomes 0. Now gauge factor equal to 1 plus 2B. This you have to consider if, only if the change in resistivity doesn't take into account. If there is no change in resistivity, then the formula is this 1 plus 2B. Okay, this is derivation for gauge factor, the most important one. Right. Now let us move on to the last concept of this unit, photodiode. Photodiode. This is the symbol of photodiode. Photodiode is basically a PN junction device. Okay, but it operates only when light falls on it. Only when light falls on it. And in forward bias condition, In forward bias condition, it just acts as a normal PN diode. But in reverse bias condition, the actual working of this photodiode comes into picture. Okay, so that this is mostly operated in reverse bias condition only. When light is fallen on the interface of PN junction, it tends to generate charge carriers, and these charge carriers will move so that it will constitute electric current. So the photodiode is a semiconductor PN device whose operation is limited to reverse bias region. Okay, the photodiode is connected in reverse bias condition. See here, the positive terminal of battery is connected to N type and negative terminal of battery connected to P type. Okay, this type of biasing is called reverse biasing. The photodiode is connected in reverse bias condition. So in reverse bias condition, what will happen? The depletion region width will increase. Okay. Since the depletion region width is very large, it doesn't constitute any electric current. But there is a small flow of current which is due to minority charge carriers only. Okay. So what I will do here is I'll put a window and make light fall on this window such that this it's actually it is a lens here. So light is concentrated at the junction only. The fallen light is concentrated on the junction only. When the light is incident through a glass window on PN junction, the photons in the light bombard the PN junction and some energy is imparted to valence electrons here. Means when the light falls on this junction, what will happen? Temperature here increases. The light photons will bombard with the silicon atoms present in the PN junction, PN diode. So what will happen? Silicon has 4 electrons in its outermost orbit, in its valence orbit. All the 4 electrons will be in covalent bonds with the neighboring silicon atoms. So all the electrons are in bond now. So there is no electric current actually. But when the light is incident on this junction, the photons will collide with the atoms of silicon such that the valence electrons take energy from this bombarded photons, and these electrons will now break the bond and come outside of the bond so that these electrons will become free electrons. Okay, the more the incident of light, the more is the breaking of bonds occur in the PN junction. Therefore, large number of electrons will become free now, and these electrons move randomly due to this supply here, due to the electric field across the across the PN diode, such that it constitutes electric current. So if more amount of light falls on this PN diode in reverse bias, more will be the flow of current. Thus, what will happen means the valence electrons are dislodged from covalent bonds and become free electrons. More electron hole pairs are generated here in this junction. Thus, total number of minority charge carriers increases and hence reverse current increases here in the PN diode now. This is the basic principle of operation of PN photodiode. Okay, photodiode is the basic operation of photodiode. Okay, when there is no light falls, if there is no light falling on the junction, then there is no current produced in the PN diode, photodiode. But even a very small amount of current is there in the diode due to flow of minority charge carriers only. This current is called dark current. This current is called dark current. It is noted by I lambda. I lambda is the dark current. What do you mean by dark current? When no light is falling on the junction, there is no light here. So what will happen? It just acts as reverse bias PN diode. That's it. PN diode when reverse biased, the differentiation width increases such that resistance is very, very high here. Therefore, no flow of current is made possible through the diode. So, holes are minority charge carriers and electrons are minority charge carriers. Here, electrons are minority charge carriers and holes are here minority charge carriers in PN diode, in N region. In N region. So, this majority charge carriers holes will tend to attract towards the terminal of battery, and these electrons which are heavy charged particles tends to attract towards positive terminal of battery, such that this differentiation width will increase. Will increase a lot. Only these minority charge carriers, electrons, get repelled due to this negative supply. So electrons move towards the junction, and holes are here which are minority charge carriers in N region will tend to repel due to this positive charge. So holes move towards P region. So there is a small current due to flow of minority charge carriers only in the PN diode, in the photodiode. So if I don't apply any light source here, even then there is a flow of small current. It's called I lambda. It is due to movement of minority charge carriers only. This current is called dark current. This current is called dark current. Okay. If I increase this, if I increase what do you say, this light beam, okay, if I increase the incidence of this light beam, what will happen? Temperature here increases and more electrons are discharged from their parent atoms, and those electrons become free electrons, and these free electrons tends to move in electric field such that I will get high current. Okay. So these are the characteristics here. If light intensity is increased, if light intensity is increased at E5, see here, at E5 means increased energy, light intensity is very, very high here. Then for a small reverse bias also, there is a large flow of current. This is V, this is I. If I apply, if the light intensity is very less, let us suppose E2 or E1, then even for a large voltages, large reverse bias voltages, the current is very less. The current is Very